Okay, welcome to our video on function inverses. Inverse functions are like inverse operations. They're opposites. Given a function, the inverse is its opposite. The first function that you have, f of x, let's say, is going from variable x to y. The x-axis is our independent variable and the y-axis is our dependent variable. The inverse goes from y to x. So we would like to find the inverse here of f of x. So our domain and range need to flip. So what was the range, what was the y of f of x becomes the domain of its inverse. 3, 6, 4, 7, 8. And then from there, the range of the inverse is the domain of the original one. 1, 2, 3, 4, 5. The pairings are the same. So 3 would go with 4, and, well, 3 would go with 2. I'm going backwards. 6 would go with 4. 4 would go with 3. 7 would go with 5. And 8 would go with 1. So notice the ordered pairs are the same, but they're flipped. So when the 3 was in the range in f of x, the domain that went with it was 2, and they flip places here in the inverse. So that's all you're doing. So, for example, if I was to list the ordered pairs, I would say 1, 8, then 2, 3, then 3, 4, then 4, 6, then 5, 7. And then for the inverse, I would list them the opposite. I would list them as 8, 1, 3, 2, 4, 3, 6, 4, and 7, 5. Okay? The notation for an inverse is the same letter as the function with a little -1 exponent of x, or n, or whatever the variable was. Okay? I can also find the inverse using a rule. So the 3-step process to find an inverse using the rule. Replace f of x or g of x or whatever it's called with y. Okay? Y equals -5 over 4x plus 25 over 4. Step 2, solve the equation for x. That should say x. So we're going to say, okay, so multiply everything by 4 to get rid of the fractions. So I would get 4y equals -5x plus 25. Subtract 25 from each side. I would get 4y minus 25 equals -5x. Divide both sides by -5. And x equals 4x minus 25 all over -5. Step 3, replace y with x. And, oops, I already kind of did that in my head, didn't I? And x with f of x or g of x, whatever, with the inverse notation. Okay, so that would be, actually I start with a g. G inverse of x equals 4, replace y with x, minus 25, everything over -5. Okay? So replace, and again, the reason we say replace the g of x or f of x or whatever it is with y is it just is easier to solve when that's one variable instead of a g of x. Solve the equation for x. Now replace y with x, so it's the format we're used to. And then instead of f of x, g of x, h of x on the other side, we would use the inverse notation. Right? All right, you go ahead and try this one. Hit pause and then hit play when you've got a solution. And the answer here is going to be g to the inverse of x is 3/4 x minus 3. So follow the process. Replace the first variable, the function name, with y, solved for x by subtracting 4 from each side, and then multiplying both sides by 3/4 to get rid of that. Actually, that would be negative 3/4 to get rid of that fraction, so that would mean the signs here need to flip. And then you would get your inverse, take x, replace it with inverse notation, g to the inverse of x, and replace y with x, negative 3/4 x plus 3. All right, the last thing I want to show you is sometimes you will be given two functions and you will be asked if they are inverses. You can tell if one function is the inverse of another by seeing if f of g of x and g of f of x are just equal to x. So do the composition, and if you end up with everything else gone and just an x left, then they are inverses. So let's try it. All right, so we'll do f of g of x first. F of g of x. So that means we're going to take the formula for f, negative 4x plus 8, and we're going over 3, and we're going to plug the whole function rule for g of x in there. Okay, and then we're going to simplify. So that would be cancel. I would get 8 minus 3x plus 8 over, and that would be actually negative over 3. So the 4's cancel, but the negative stays. And we know that negative 8 and positive 8 cancel. We know that then we would get 3x over 3, and the 3's would cancel. We get x. We've got what we want there, but we need to check the other one. Now, if we wouldn't have gotten x there, we would get to stop. But since we found what we got on one part, we have to figure it out and make sure it works on the other part. So we would do g of f of x. So that's the same idea, but the other way around. So we're going to take 8 minus 3x over 4, and we're going to plug in negative 4x plus 8 over 3 into that rule. So we would get there 8 minus cancel. Negative times negative 4 is positive 4x. Negative times positive 8 is minus 8. Everything over 4. The 2 8's cancel. The 2 4's cancel, just like last time. I get x again. They are inverses. And the reason we say this, what this means, is that the operations here all cancel each other out. And that's what an inverse does, right? That's how we do the opposite. We make each part cancel, and then we're left with what we, in this case, put into it. And that's what happens when you do the inverse, right? If you take the one that we just looked at, if you took a value of g of x and then you put it into the inverse, you would find the original x that went with it. In other words, if you took an ordered pair, and I'll just show you this real quick before we're done. The y-intercept there is 0, 4. I'm just using that because it's easy. So if I put a 0 into g, I get 4. If I were to find g inverse of 4, I'm going to take the rule that I wrote, negative 3/4 times what I have, 4 plus 3, and I simplified it, I would get negative 3 plus 3, which is 0, the original x. So that's the number version of what we just did here. So we're trying to make sure the two functions cancel each other out. And when that happens, they are inverses. All right. Thanks for watching the inverses video.